Welcome to the presentation for the LambaDEX project, which is an effort by machine reference team members Alex, Diego, Fusco, and Perna. I'd like to start by congratulating all hackathon team members for their outstanding efforts in creating so many interesting projects. Our team believes that even though many of the chosen verticals are fun and may attract curious eyes, there really is only one proven practical use for blockchain. And this is, of course, DeFi. In the spirit, we decided to explore the design space for decentralized exchanges. Now, creating a working exchange using L1 technologies is both technologically impossible and economically inviable. Current Cartesi technologies makes this not only possible, but actually kind of fun. Nevertheless, there are still scalability issues. So our project is about how future Cartesi technologies will solve these. We are, of course, talking about Lambda. We have discussed this before. In a nutshell, Lambda allows us to inspect and advance the state of the machine in bare metal outside of the machine emulator, while maintaining verifiability. So here is a UI demo for what the exchange can do in the UI, and then we'll show a live demo in the backend command line. So here you can see the Lambda machine being created. See the Lambda there. And now you hand feed the exchange with some initial state so that you can see cool stuff. Otherwise, it's just empty. So people getting money, and then a bunch of deposits happening. And then some trades are being asked, right? So somebody is trying to sell Dodge, sell Dodge to USDT, and so on and so forth, like a bunch of sell orders. So this is multiple pairs. And now you're going to see the UI view of these order books, right? So you see there you can choose a pair, and now it runs the inspects and gets the data from the machine, right? So you see all the stuff happening in the background. Okay. Oh, get out of here. So now the backend demo. Let me try to share a different. Let me show you how I'm doing all this stuff. So how do I stop sharing? Stop streaming. Share again. Now let's share another window. Just this one here. Live. Can you guys see this? Yeah, cool.
We can, yeah.
So I'm going to create the executables that I need, the file system for the DApp. And now I'm going to create some inputs and some queries. I'll show some of these later on. And now I'm running things inside of a Cartesi machine, right? So all these inputs, and you can see that the Cartesi machine was created with a Lambda drive here that is shared, right? And the application was run to initialize this, right? And you can see that it received inputs and input metadata, and it advanced the state, and it generated some notices and so on and so forth, right? Bunch of stuff going on. So I can show you what one of these input-output situations could be, right? So you can see that there's an Diego sent a new order, right? And the order was to sell CTSI for USDT 500 at a certain price. And you see the notices that the exchange generated. First, the notification of the new order, then an execution. Perna wanted to buy, right? So this part closed. And this part closed because it's for the other side, right? Now, you can run certain queries again in the Cartesi machine, and you see that the machine was run now without initializing the Lambda state, because the Lambda state was shared, so it's already outside of the machine, so it's going to pick up where it left, and it processed some queries, right? I can show you one of these queries. For example, this is a book query, right? Which is, I want to see what the book for CTSI USDT is. And here's what the report was generated, right? So you see a symbol here. The order book has trader Perna trying to buy and trader Diego trying to sell. And now comes the cool part, right? So I can actually run on bare metal the queries. And to do this, I can use actually a JSON RPC server that is basically loading Lambda, the state, and is receiving a query, right? So you receive the wallet query for trader 2. I don't know if this is me or Perna. It doesn't know the names of the people. Only the front end knows this, right? And then it sent another book query, right? And it produces the result in JSON. So this is a bare metal running, right? Now I can go further and I can actually run the inputs bare metal, right? So this is a DApp running in the host. It initialized another Lambda, right? File here. It ran all the inputs, right? And now I can do and check that the diff between the one that was generated inside the Cartesi machine and the one outside doesn't exist. There's no difference, right? So here's what you saw. You saw running in the Cartesi machine a wallet and order book written in C++ with heavy use of C++ standard libraries of data structures, supporting multiple users, tokens, and order books. And then you saw a JSON RPC inspect server that quickly answers queries by running the same C++ code bare metal to access the same native state that was created and modified within the Cartesi machine. And the cherry on top is you saw the same code running bare metal, accepting inputs, but creating and modifying the same native state in the same way that matches the Cartesi machine. Now, how is this even possible? So this is possible because we share the state between what is emulated and what runs in bare metal, while mapping it to the exact same region in the address space of the processes involved. So all state ends up there because of our allocator, and the representation is the same because we use the same standard library implementations inside and outside. So I'd like to thank my team. They are awesome. And if you have questions, please join us on Discord. Thank you.